Hello and better late than never. This is going to be back in Unit 3. This will be a section talking about, and if you take a look right up here, it says convection tectonics. I'm actually getting this from geology wwu.edu, and if you actually type in probably this and this, you'll actually get it, or maybe even that into Google. You'll actually come to this. But basically what this thing is going to do is it's going to show all three type of plate boundaries, all of them underneath an ocean. So it's not really showing the continents, but it does show some islands sticking up caused by the subduction. But when I push play, what we're going to see is we're going to see divergence. So down here we actually have a relatively hot area. It's making magma rise. Comes up and hit the lithosphere. Lithospheric plate made up of the oceanic crust and the upper mantle will actually get stresses. It'll melt a little bit and get stresses and eventually start moving in both directions. So we've got divergent around these two things. That's the Rift Valley. This would be a mid-ocean ridge, and there's another one over here. This is actually the well, in between these two mid-ocean ridge offsets is going to be the lateral faulting, where this plate moves off to the right and this plate moves off to the left. And these are the fracture zones where they used to be uh, the section in between the two offsets, but now they're actually being pushed off. So you can see this plate's moving and that plate's moving, and eventually they become one. But there is going to be a fracture line in there until it gets covered with sediment. But that is pretty much tectonically dead. At least now. And then the plate moves off in a direction. This one moves off to the left, this one moves off to the right, this is a left, that's a right. And eventually on this planet it's going to go all the way around, and this plate would run into this plate unless there's another mid-ocean ridge someplace around, or it's going to hit a landmass and move it around the way it is today. But if we had a water world, we would still actually end up with basically an area where the two plates are converging. So we'd actually get a subduction zone, the associated deep ocean trench forming, the oldest oceanic rock going this way, the oldest oceanic rock going this way. And if we looked at the place there and we looked at the place there, the rock would be the same age, although this plate would be getting older and this plate would be getting older because we're actually killing the plate. Even the plate that's not being subducted is getting worn down, sort of like sandpaper, as this plate subducts. So what we're going to watch is we're going to watch this oceanic plate subduct. We're going to watch it get down to this location. This is why we get shallow earthquakes and we get intermediate earthquakes and deep earthquakes here, where we just get shallow and intermediate earthquakes there, and pretty much just shallow earthquakes along with these guys. But these are all going to be on top of each other, where these guys are spread out. So we can actually tell just by looking at earthquake position the type of plate boundary with it, especially if we can find a deep ocean trench or a mid-ocean ridge there. So this plate goes down, it gets to a point where it actually starts getting melted. No more earthquakes going on because you're not going to get stress built up in a liquid, even though it's more like silly putty. But what's going on is the material that was up at the surface doesn't want to be down here. It's actually now hotter, so it wants to go up, and it'll go up and it'll punch volcanoes on the and if we actually push this plate down, this will be the cave section of it. This is the convex. Actually, this would be the concave, and this is the convex side. So on the convex side, you'll actually get these islands. These would be an island arc, a long chain of islands, all volcanic. And so let me push play and let's see how this thing works. So there's the divergence, there's the lateral. We can also get what's called subducting plate downwelling. So this plate will actually start pulling, slab pull wise, pulling this plate down. A quick stop. So this plate will actually get pulled down because of the weight, which may actually start causing this to be ripped apart. And there is a little bit of discussion on whether we get this upwelling to pull it apart or we get this slab pull to pull it down, but it's probably a little bit of both. And it continues until we get to the end, and that's where I'm going to stop. So that's pretty much the way this one works. Thank you for stopping by.